Now, we're going to, it would be great if we could stop there. And we take a look at these 4 questions. Square root of 5, square root of 8, 3, square root of 3. They are still fractions, you just don't see it. It's over 1, over 1, over 1. Even this 2 is 2 over 1. And what we're going to find in these next examples is that there's going to be we're going to simplify it a little bit, and there's going to be a square root on the bottom. And we're technically not allowed to have that. I mean, it still is correct, but we need to do something. Mathematicians like to not have square roots on the bottom, and they call that rationalizing the bottom, or rationalizing the denominator. We want to have a whole number on the bottom, or the denominator. So we need to do a little bit more work. So example 7. First, we're going to learn just about rationalizing. We can't do, there's no square root. This is not a question that shows square root of 5 over the square root of 10 where we have to merge them. There's only one radical symbol, it's on the bottom. So when we get an answer, and we'll get here, but when we get an answer that looks like this, we're going to have to rationalize it. To rationalize it, you need to multiply by the bottom. So square root of 7, I'm going to multiply the square root of 7. And the reason I do that is because the outside numbers here, they're both 1. So 1 times 1 is 1, which I don't need. And the inside numbers are 7 times 7, which is 49. So square root of 7 times square root of 7, the insides multiply together, you get the square root of 49. And the square root of 49 is just a 7. So we've turned something that has a square root on the bottom to now something that's a whole number. And the only way to do that was to multiply by the exact same thing, but it has to be a square root 7, and this has to be a square root 7, so it has to be identical. But when we do that, you have to actually multiply the top by the exact same thing. So 2 times root 7. Well, 2 is an outside number, and there's none here, so that's just going to be a 2. And root 7 is an inside number, and there's none there, so I guess I just have an inside number of root 7. And root 7, I can't split up into 2 numbers, it's already a prime number, so it just stays 2 square root 7. And so this is considered rationalized. There is no square root on the bottom. Does it look any nicer than this? No, I actually think that this looks a little bit uglier. However, our whole point is to get rid of the square root on the bottom, and we have now accomplished that. So this is going to take some time, but we're going to try another example. So here you say the square root of 5, square root of 7. You could join this into a fraction, a one giant radical with a fraction in it, but 5 and 7, that can't be reduced. 5 and 7 can't actually become a simpler fraction, so there's almost no point. And the question also asks, just rationalize it. Okay, so to rationalize it, you would multiply by the exact same denominator. In this case, square root 7, and then multiply by square root 7. But whatever you do to the bottom, you have to do to the top. So I'm going to multiply by the square root of 7. So the outside here number is a 2. There's no outside number here, so I'll have a 2. And the square root is a 5. The inside number is a 5, and the inside number is a 7. So 7 times 5 is 35. On the bottom, there is no outside numbers, and the inside numbers are 49. So here we have, I don't know why that keeps disappearing, 2 square root 35 square root 49. So I've got 2 square root 35. Again, I could join those fractions together, but the square root of 49 is a perfect number. I can just make that a 7, because it is, square root of 49 is just 7. Now the denominator, or the bottom of the fraction, does not have a square root, so we consider this done. The next question over here is C. Again, I can see that 5 and 3, if I join them together under one radical sign, I can't reduce it. It doesn't become a whole number. I can't make it a simpler fraction. And it doesn't even ask me to simplify. It just wants me to rationalize. So when I rationalize something, I need to multiply it by the bottom. Whatever I multiply by, I'm going to do the same thing to the top. Well, I could multiply by the bottom, which is negative 2 square root 3. But as it turns out, you don't actually need to multiply by the bottom exactly. You just need to have the square root part. So the square root of 3 and the square root of 3 is all that's actually required. So I'm going to have on the top, there's a 6 on the outside and a nothing. There's a 1 there, so it's going to become a 6. And the inside numbers are a 5 and a 3, which is a 15. On the bottom, I've got a negative 2 on the outside and nothing over here, so that's going to be negative 2. And on the inside, 3 times 3 is 9. Now the square root of 9, there's a 6 and negative 2. The square root of 9 is just a 3. And the square root of 15, is not a number that I know. And sometimes you're going to simplify it. You think 15, I'll break that up to a 3 and a 5. And I can't go any further, and there's no pairs, so there's no simplification needed here. So I just need to leave it as square root of 15. Now the top is a 6 square root 15, and the bottom is a negative 6. And these can both be divided. The outside numbers can both be divided by 6, so I'll do that. So I have 6 divided by 6 is 1 square root of 15. And then negative 6 divided by 6 is negative 1. Now I don't need the negative 1 on the bottom, I can throw that up top. So I'll put that at the top. 1 square root 15. And then we don't actually need to write the 1 in front as well. So again, this negative can be thrown up here. But we don't need to write the 1, we can just write negative square root of 15. And that is the simplest answer.